All right, hey everyone. So today is 1st May, and I welcome you all to the Certified Meshery Group Study Hall. And in this study hall, we talk about the CMC certification, that is the CNCF one of its kind certification, and we help you prepare about it. We have different units that we have covered in the past, and we also record these sessions and upload it on YouTube. So if you are someone who is joining for the first time, you can start from here, or you can also watch the previous recordings. But talking about today, so we have a special session, and our guest is Yash today. So he will be walking us through a core topic in Meshery that is quite extensive as well. That is Meshery relationships. So he will be sharing about and walking us through what are relationships and doing some deep dive upon it. So before moving on to that, one housekeeping item that we follow in the call is to mark your attendance over here in the attendees section. So I'll be sharing the link to the meeting minutes in the Zoom chat. If you are attending the call, uh, so please mark your attendance. That would make us that okay, you have attended the call, and you can turn on your webcams to make the session more interactive. So I think let's get started. Yeah. Yes. Feel free to
Yeah.
hop on. Yeah.
Thanks, Ronak. I wouldn't say I'm a guest here, but I would like to share whatever I learned here, whatever I got help for. So, mesh relationship is actually one of the interesting topic that attracts me when I joined this community. Before anything, let me introduce myself. I'm Yash Mahakal. I'm finally a computer engineering student from Pune, India. I'm here a community manager, and I have worked extensively on mesh relationships. So here's my chance to give back to the community, and I would like to grab that. So yeah, thanks all of you. So yeah, talking about my experience about the relationships. So mesh relationship is one of the interesting topic that will be attracting so many of the newcomers, so many of the contributors here. And talking about the relationships is a thing that actually makes the Meshery go, that actually makes Meshery meaningful, because it actually lets two components interact with each other, and it actually lets you to define your infrastructure. So let me share my screen first. So I hope you can see it clearly. So we were talking about domestic relationships. So as I introduced myself, I'm one of the community manager here, and it's my first time doing any workshops. So yeah, I would definitely expect help from you guys. So talking about relationships, it's actually a subcomponent of the models. And before having a deep dive into the relationships, I would like to talk more about models. Talking about the Meshery models, so models are the units of packaging. You can assume it as a large container which will be holding the further components in it. So models is the outer carton which will be acting as a unit of packaging for definitions of Meshery's logical object representations. Now, talking about logical object representations, then we actually treats the components relationships or the entities that we'll be using in Meshery in terms of models, components, and relationships as the logical objects, and we'll be representing them into the models. So for example, Kubernetes is actually a model in Meshery. Kubernetes is a system where you can find some of the components like pods, deployments, and any other components, for example, config maps, stateful sets, daemon sets, and all those things. So these are the components, and Kubernetes, which actually encapsulates all those things, is actually a model for them. So for better understanding, we have actually a contributor training series on machine models by Abid Sofi. So you can check out this workshop also. So let's talk about machine models more. A directory structure. Before starting anything else, let's know about where relationship lives and what models have. So talking about the machine models directory structure. So models are actually the units of packaging for definitions of machine logical object representations, and each model is versioned and encompasses a collection of components, relationships, policies, connections, and credentials. So these names are pretty explanatory on themselves. For example, components, as I said, if you are taking an example of AWS or Kubernetes or any other model, then components will be its subcomponents. For example, for Kubernetes, it is deployments, pods, or anything else that actually has a Kubernetes that actually comes under the Kubernetes. And then talking about the relationships, now I will be talking about relationships in deep, but for your curiosity, so let's assume we have two components, for example, a pod and a deployment. So pod and deployment are actually relatable to each other. They actually related to each other. If you are talking specifically about deployments and pods, then a deployment can't exist without a pod, right? A pod can be a standalone without the deployment, but a deployment can't live without a pod because a deployment need pods. And same wise, pod needs a container in it because if there is no any container pod, it's not useful or it won't stand. So that's how they are independent, interdependent with each other. They have a dependency. So that's what is a relationship. And in terms of mesh relationships, we are gonna logically define the relationship between them using a structured file in JSON or either in YAML format. We'll be taking a look at those files and all those things later. But let me continue with the remaining items. For example, policies. Policies helps to define the policies for the relationship evaluations. Then connections and credentials are the helping components for models in models. So it's just out of the scope right now. So instead of going forward into them, let's move forward with the constituents of the models. So these are some of the standard and casual definitions of the constituents of models. For example, if you are talking about components, then components define the basic units of infrastructure, but can in fact represent anything. For example, individual parts of any system. For example, services, databases. For example, in terms of AWS or like in terms of AWS GCP, all the services, for example, AWS have AKS, for example, EKS, that is Elastic Kubernetes Service. So it is kind of a component for AWS. AWS has Google has GKE, Google Kubernetes Engine. So that's a component for Google. Same with Azure. Azure have AKS, that is Azure Kubernetes. So it is actually a component of AWS. Likewise, for Kubernetes, pods, deployments, and all other are the components for Kubernetes. Talking about the relationship, then as I explained or as I state, as I gave an example of deployment and pod, there can be so many of the relationships. So relationships actually define interactions and dependencies between components within a model. So this is a very actually familiar term in terms of logical entities that to define the two things, you need to define them logically with relationships, and they should be meaningful. If they are not meaningful, they are of no any use. So that's how we are going to define the relationships. Talking about the policies, so policies govern the behavior and constraints of components and relationships, ensuring adherence to the desired operational practices. For example, relationship evaluation policies. We have some of the policies defined in relationships or in Meshery. So they will be the part of the policies that they will be making sure that relationships, components, or models will be adhering to the standard rule set that we have defined here. Talking about the connections, then connections represents managed or unmanaged resources discovered automatically or entered manually. So, and we can maintain them as stateful entities used across one or more environments. And credentials, so just a casual definition, credentials define the authentication details used by Meshery to access managed or unmanaged connections securely. So you might have idea about from these definitions. So let's move forward with the components. For example of components. So as I stated earlier, so every model contains its respective component. Say for Kubernetes model, we can see some of the components like daemon set, pods, namespaces, replica sets, ingress. So component is a fundamental building block used to represent and define the infrastructure under the management. So in terms of models is the outer carton, and you will be having the building blocks like this for the Kubernetes, for example, daemon sets and pods and all those things for Kubernetes. So these are the components, and each component will be providing a granular and specific support for infrastructure and applications. So since our target is to go YAML free, we really don't want it to have that headache or that problem with the YAML. We just hate YAML at Meshery. So that's the reason we are having those components, models, and relationships. So we'll be using them in a canvas. I'll be trying to show a demo also. So let's move forward with the topic. So yeah, talking about the relationships in Meshery. So mesh relationships actually characterize how components are connected and they will be interact with each other. Because having just component doesn't make sense. There should be interaction between them. If you are dragging some of the components on the canvas and then deploying them, they will be there just as standalone. There won't be any process going on. There won't be any value from them. So to make our infrastructure, we need to connect dots there, because whenever you are configuring any YAML file or anything else, for example, if you are working on any like uh, containerizing any application, you need to use pods. Then you to expose those pods, you need to use what we can say as uh, services and all those things. So just a minute. Yeah, all those things. So we need to service to expose them actually. So talking about this type of conventions, we need to connect those dots and we need to configure them within each other to make them work. So that's all we call as a relationships, and that's all we call as a connecting or interacting with each other in terms of components. So this is all about the relationship. This is the definition of the relationships. Now moving forward with some of the practical things about the relationship, since we are gonna work with the relationships today, and this is the topic we are here for. So actually I would like to show the actual code base for that, or maybe we can go with some of the theoretical concepts, but yeah, I think we can go with them laterally. So yeah, as you can see on my screen, it is there are some of the types of the relationships. For example, semantic relationships and non-semantic relationships. Talking about semantic relationships, so semantic relationships are meaningful in terms of how Meshery manages entities and their life cycle. Semantic relationships are actually the relationships which will be having a life cycle and which will be having some effect, or they will be having some of the processes. For example, talking about a Kubernetes deployment and the namespaces. So it is actually a semantic relationship between a Kubernetes deployment and namespace, because we know that in terms of namespace and Kubernetes deployment is always placed in a namespace. So it is a semantic relationship because it is making any meaning, and it is not a visual only. This is actually a practical thing. This is actually a thing that exists, or this is actually a thing that we can deploy. If you are drawing a namespace or dragging a namespace on canvas, then putting a deployment in it, and then if you are deploying it, it will be actually generating a namespace and a deployment on your cluster. It won't be just design only or anything else, or it won't be meaningless. And talking about the non-semantic relationships, so it is meaningful for user understandings. The way we just like add some comments or anything else on canvas or like any other word. So it is just for the user understanding to guide the user, and they will be ignored by Meshery's life cycle management engine. For example, rectangle shape enclosing any components. It's just a just common practice that okay, if you want to show that something is something is consisting something, then we just do that. Okay, take a shape and then drop anything else into that or like that. So it is like that. So non-semantic, talking about non-semantic relationships, it's just for the user guidance. It won't be having any effect on any process, or it won't be running any process, and it will be ignored by Mesh's life cycle management engine. So moving forward with the next, some of the theoretical parts that we need to cover is, yeah, before that, I would like to show something. Yeah, my control with Zoom is so wrong. I can control Zoom well, so just apologize. Okay. So I hope I can have a relationship to show. Yeah. So can you see my screen, my code editor? Hello.
Yes, yes, we can. Yeah.
Yeah. Okay,
Yeah.
so this is called as actually relationship JSON, which is actually relationship schema. We have talked about the Meshery directory and how it holds together everything together. So talking about where you can find those mesh models or the models that we have in Meshery. So you will find them inside Meshery. Then there is a server. If you are going into server, you can find mesh models, and you'll find all those models there. For example, Meshery is currently having total of 391 total of integrations, and you can see so many of them. For example, action runner, control, admin console operator, aircube. Then you can find AMD GPU, Antria, and AWS. So these are the AWS models. You can find so many of the models, but since AWS is one which is familiar with, which we are familiar with, so let's take example of Kubernetes. Just a minute. Yeah. So talking about a Kubernetes, then so as you can see, it is a Kubernetes model, and inside it is a version of the Kubernetes model. So this is a version 1.35.0. So, and inside it, it is a version that we use for the this type of relationships here in Meshery. So inside this Kubernetes model, this is called as a model, and inside it we have a component, and inside those components, you can find some of the components. For example, API service, then you can find cluster trust, then you can find cron jobs. So these are the actually component schema or component configuration files, which we call as component.json files. So you can find them here. And this actually suggests that what a component does and what it is actually having and what capabilities it will be actually having. So just a quick look at component.json files. So this is the ID. Well, you will be finding ID for all models, components, and relationships as null. I'll be talking about why it is null or anything else. But just for your curiosity, I'm just demonstrating all the parts. By the way, this is a source URL. Whatever models and whatever components or whatever relationships you will find in Meshery are actually generated through the standard CRDs, that is custom resource definitions that we have for those particular type of models stored on GitHub. For example, talking about AWS, we have ACK controllers. For AWS, we have Azure Service Operator, which actually provides those CRDs. So yeah, this is all about the components. And if you are going further, you can find a relationship folder alongside the components. And in this, you will find the relationships defined. So you might find so many of the different names, and they are, if you're saying there is a pattern between them, we'll be talking about them. But since we have mentioned some of the things like semantic and non-semantic, so how a relationship is can be called as semantic, and or how it can be called as a non-semantic. So this is the one thing that decides if it is a semantic or non-semantic. So is annotation means you are known about annotation. Annotation is to guide user. So if you are having annotation as a false, that means it is a non, it is a semantic relationships. That means it will be have a production meaning, and it will be running some processes there. And if it is turned as a true here, so it will be saying that, okay, this is only design only, and it won't be running any process or it won't be configuring anything. So this is the field that actually decides if a particular relationship is actually a semantic or non-semantic. So you can find this is annotation in one of the top block in the metadata field, and this is what actually decide if a relationship is semantic or non-semantic. So let me just go to slide screen. So now, moving forward with some of the types of relationships. Relationships is not like you can have only a one type of relationship between two components. Talking about some of the relationship types, there are some of the relationship types like hierarchical relationships, then age relationships, tacit relationships, or sibling relationships. So, talking about the hierarchical relationships, so they actually represents a parent-child dependencies, and they shows a clear linkage like a family tree. So, we are aware of object-oriented programming goals. Like when we are talking about object-oriented programming, there is something called as a inheritance and inheritance. So it is like inheriting parent properties into child or like that. So this is how this is similar here in Meshery. So when you are describing any hierarchical relationships, so it actually represents a parent-child dependencies. Moving forward with the relationships. So sibling relationships are the components that actually shares a common origin but operate independently without direct dependencies. Then there are age relationships, which are actually visually depicted as ages, connecting components defining how they interact. So talking about the hierarchical relationships, an example can be a pod and a container. A container is necessary for a pod to run. If you don't have a container mentioned in a pod can't run. And that's the hierarchical relationships. Now, how it's hierarchical, then we place a container into pod. It's not like we just reference a pod into or reference a container into pod. We just put down it in a pod. Uh, it is actually a component of the pod. Uh, a container is actually a component of the pod, and that's why it is a hierarchical relationship. Same is with namespace and deployment or any other Kubernetes resource. If there is not there is no any namespace, you can't actually define any resources into it, because when you are actually setting up your Kubernetes cluster for the first time, you'll be seeing that there is at least one namespace and it is called as a default namespace. So whatever you are trying to deploy, if you haven't created a namespace, it goes under the default namespace. Same thing happens here. Namespace is actually a parent for the components like uh, pod, then deployment, or any other thing like service or any other thing. So this is how hierarchical relationships works. Sibling relationships are like the components that actually share common origin. For example, you can tag or like label two components as the same. They actually don't have anything to do, like anything to interact within them, but they are just sharing the common label, and that's why we are grouping them. So it is for the grouping, and that's why we call it as a sibling relationships. And the age relationships are actually visually depicted as age connecting components or defining how they are interacting. For example, there is a persistent volume claim and a pod. So we know that in terms of pod or deployment, if we want to summon uh, any storage into them, we need to reference a pod or sorry, a PVC or like a persistent volume claim, a storage class, or any other solution that we have into the pod or deployment. So it is like a reference type of relationship between them. It is so this is what we call as a age relationships. So we were talking about taxid relationships in more detail. I don't want just to be confused and really don't want to confuse people. So let's move on the next topic. So let's start with some of the age relationship types that we have in Meshery. So age is actually a type of the relationship. Let me just move to the code base so that you can have idea of it. Okay, here it is. Yeah. So you can see there are some of the things like kind. So kind is actually a main type of the relationship. It can be hierarchical, it can be age. So as you're seeing here, it is a kind age type of relationship. If you're scrolling further, you can see a subtype here. It is type of network, subtype of network, and it is a type of non-binding. Now, what those other two fields mean, I'll be explaining them in the next slides. But just wanted to position where we are using those things. So we can use kind here just to mention the main type of our relationship. So let's move on the slides again. So edge network, talking about the edge network. So it is actually for the networking use case. For example, a service and a deployment. So it's not like we are referencing the service. Service is actually forwarding the traffic to the deployment, or like we actually need service to expose the deployment on maybe on node port, on maybe on cluster IP, or maybe on load balancers. So to talking about the edge network, it says that it configures networking between components. For example, in terms of Kubernetes model, service, and deployment. So how you can determine like it is edge network or not? Like, can't it be edge reference or any other type of relationships? Then you should be asking a question like, does one component actively forward, route, or route balance web traffic like HTTP, TCP, UDP to the other component? And that's what service is doing, right? So that's why we are saying that it is an edge network. In terms of any other relationship, for example, I can take an example of a secret and a pod. So secret is just getting referenced into a pod. It is not sharing any networking component, or it is not related to any networking thing in in these relationships. And that's why we call it as a edge reference or any other type of relationship, but not edge network. But in terms of service, in terms of load balancers, in terms of any other thing, when it's about the networking things, uh, it is a edge network kind of relationship. And the simple example I'll be showing is about that show you. It is a network one. As you can see, it is a network one. So it is between an ingress and then a service. So we know that ingress, when you are actually trying to reach to a pod, we actually bounce with the ingress first. Like we actually faces the ingress first, then ingress actually forwards traffic to the service, and then we reach to the pod. So that's how it works, and that's why we are calling it as a network relationship. It is actually acting as a network bridge between them. So this is the reason why it is a network relationship. Now moving forward, the next. age reference relationship. It is the most common relationship you will find in Meshery code base. I can say like 60 to 70% relationships currently are age reference. So what age reference relationship is? I've given you an example of like pod with a secret, pod with a any other like for example volume or any other like config map or anything else which actually references an environment variables or like maybe a name of any container or a name of any other workload. So those are the age reference because they are not sharing the networking concepts. They are just getting referenced into each other just to work. Because when you are talking about a secret and a pod, when you need your secret to act as a provider of the credentials or the environment variables that you will be holding, you need to reference them into a pod or like into a deployment, and then it will be working. So it is just sharing the values and not any networking concept. So that's why it is called as a edge reference relationship. So talking about age reference relationships, it is a logical or declarative links between a components where one component refers to another by name, identifier, type, or scope. So these words are important here, like by name, identifier, type of scope. For example, AWS EC2 model instance and an elastic IP address. So it's not like elastic IP address will be providing the IP there. We'll be just mentioning this elastic IP's ID into the instance. So that's how it is working. So this is called as age reference relationships. Or if this might feel like a strange example, you can take example of anything like for example a pod configuring with a config map. So config map is holding all the environment variables and the values, or what we can say as identifiers or like your secrets or anything else. So they are getting referenced in the pod or in a deployment or static set daemon sets. So that's how they are age reference, because they are getting referenced into each other. It's not like they need each other to work. A pod can work without a config map. A pod can work without a secret. A pod can definitely work without any other thing that actually be working as a reference. So that's how it is working in terms of age reference relationships. We can take a look at some of the age reference relationship for sure. Okay. So here we can find one relationship called as a age reference relationship. So it is between Kubernetes components called as API versions and then API resources. So here is this one is a network type, reference type of relationship. Same with another component called as a replication controller here, and then with config map here. So in terms of here in replication controller, it just need the name of the config map, right? Here in this field. If you are putting the name of the config map here in this field, like under configuration spec, then templates, spec volumes, and then config map and name, then it will be using that config map. And here, the same name from the config map, you can see here, will be giving to will be flowing to this. Now how it will be flowing is the most interesting part of this workshop, and I'll be talking about this in a bit once I have cleared all the theoretical concepts. So yeah, I just noticed that time is flowing away. So let's move forward with the age permission relationship. So age permission relationship actually defines how components connects to establish access control, where binding components like subjects to roles with specific permissions. So in terms of AWS, we know that we need to assign some of the policies, some of the roles when you are wanted to actually work. It is prescribed. It is standard practice to not use the root account. In terms of AWS, you need to create an IAM account or like that. So IAM role or those things. So it is the same for this. So if you are taking a look here, here is a policy. This is a role, and this is again a role. Now, what I mean by age permission. So in terms of some of the components work as a grantee, or like the one who will be having all the permissions and set of the permissions which will be giving the grant to the grantee. Grantee is one who will be having all the access or all the permissions to do something functional or to perform some functions, and one who will be granting will be the one who will be giving the grants to the grantee. So in terms of here, if I have to explain this image. Then policy is actually I am policy, and if you have used AWS, you know very well that if you want to use if you want to do anything, if you want to perform any work, then you need to have some set of the policies. You can't do it otherwise. So for that, even for the S3 bucket or like any other thing, you need to have those policies defined. So here a role is created. Here is another role, and this is a policy. So this policy is actually attached to these roles so that these roles can actually work, and those roles won't be having any problem when performing any action. So this is kind of age permission relationship. So it will be defining how components connect to establish access control. So you can manage the access control with this kind of relationships. Talking about the age mount relationship, we know that we mount the volume. We just don't refer like or like we just don't reference a volume or anything else. We know we actually mounts the volume, and that's why in the Kubernetes term we said that volume mounts whenever we are configuring any volume into any workload. So talking about age amount, it actually represents the assignment of persistent storage to a workload, typically modeling how a pod claims storage via persistent volume claim. So as you can see in this image, so this is a deployment, or you can call as this is a pod, and this is a persistent volume claim. So we actually mounts the volume into the pod, and that's why this kind of relationship is actually called as a age mount relationship and not age reference, because we are not referencing any label in name or like any environment variable. Neither we are sharing any credential related credential or any set of permission or any role. Neither we are configuring any networking components, but what we are doing is we are mounting something here, and this is called as a age mount relationships. Because if you are not mounting it, you won't be having that option to use the storage for pod. So this is how it works. This is called as age mount relationships. There is a next one, and it is a bit interesting, to be honest, because we have just seen something called as age network relationship, and now we'll be talking about age firewall relationships. So this acts as an intermediary for communications, which includes standard networking protocols like TCP and UDP. So it can actually enforce network policies to control traffic between the components. So talking about a firewall, everyone is known about a firewall. So talking about a VPC and a security group. So what security group does, I think security groups are stateful, and what they do is they allow or disallow a specific uh, request or like a specific routing traffic. So that's what security group will be doing, and they will be having some of the rules configured. So a relationship between a VPC and a security group can't be just referenced, because it's not like we are referencing security group into the VPC. It's not like we are gonna mount the security group into VPC. It's definitely not like it's just a network, like we will be just accessing the VPC through the security group. It's like security, yeah, we'll be accessing the VPC through the security group, but security group is doing something different. Security group is actually having the rules defined if it wanted to allow a specific request to the VPC or not. And that's why it is called as a edge firewall relationships, because firewall we use to actually secure our connections, and that's why it is called as a edge firewall relationship. And this is a type of edge relationships. And yeah, most easy and easy to explain relationship is age annotation relationship, and it is a type of non-semantic relationships. So it is just a relationship between components that are strictly for the visual purposes. For example, you can see, so here it's not like there is you need to make any logic here. It is just this green arrow. Whenever you see a green arrow on canvas, just understand it is a age annotation. It is just used for the annotation. It is just used for the labeling, or it is just used for the visual purpose, and it is doesn't have any meaningful relationship. Definitely these relationships will be meaningful, but for the user preferences and for the viewing pleasure only. So that's why it is called as a age annotation relationships. Now yeah, let's take a look at some of the relationships in code base. For example, we have some of the relationships for them. Can you see my ID?
Yeah, we can.
Yep. So for example, for its reference, you can see some of the reference relationships here. For example, this is related to AWS MQ controller. It is a reference type of relationship. And since the two components that are here, for example, we have a broker, MQ controller broker, and then uh, what is next one? Yeah, and adapter resources. So the relationship between AWS, I'm really sorry if you are not, because this is the example I found. So if you are aware of the AWS, then this are components which actually demonstrate the reference relationship. Because as you can see in here, you can see it is just asking for name or ID, and it is not asking for any port. It is not asking for any rule set for the firewall. It is not any visual relationship. So it is just asking the name, and the broker is actually providing its name. So that's how it is a reference. Now there is one more called as a mount we saw. So here is a one with mount. So you can see it is about AWS EFS controller, that is Elastic File System. So it is between cluster and it is between a file system. And as I said, for the cluster, what you need to do is mount a file system, because when you are talking about the storage options, you need to mount them. You can't just reference them. You need to mount them. And that's why it is having a type called as mount and binding. So that's how it works, and that's an example of mounting relationship. Let's take an example of firewall. So this is for the firewall. As I said, this is the AWS VPC CNI. That means AWS VPC. This is a policy endpoint component of that, and it is a security group, just like I show in image. So this is the relationship between VPC and a security group, and as you can see, it is not just asking the name or anything else. It is actually just pointing to the security groups. It is not asking any credential. And that's why it is having the relationship of the firewall, because uh, state what I can say, security groups will be providing the firewall for them to secure and to have rule sets defined. So this is all that we have. And let me see if you have any age annotation type of relationship. So this is called as a age annotation type of relationship. No, I think this is not. And yeah, I found one more thing, that the file name is wrong here, so we need to change it. Yeah, no worries. Let's move forward. Time is draining out. And talking about hierarchical relationships, now this is gonna be really, really interesting part. But before going to the hierarchical relationships, I would like to talk about the schema of the relationship JSON files first, and then we can move forward with it. So yeah, fields in relationships. So as I said, this is how a relationship JSON file looks. There are some of the fields and they are necessary, they are important. You can't drain them, or like it's not like you can just configure anything there. They are actually bounded with some rule sets, and I'll be talking about them now. So talking about the fields in relationship definitions. So I have added some code snippets talking about this ID field first. It is the unique UID for the designs or for the relationships. So this is the ID which will be used to identify the relationship files. But here is a catch. You will find all the IDs in the Meshery repository are set as a null. They are not having any value. So how they are gonna actually get, so how from this ID we can actually identify the relationships. So the Meshery server actually registers these IDs during runtime and makes them actually the unique. So let me show you how and where it does. So can you see my terminal, Ronak?
Yeah.
Yeah. So if I go in here, missions, just, let me check my, okay, it is working, no worries. So, okay, I guess I need to turn on my server for that. Okay, let's move it for later. We can talk about it later. So yeah, this ID will be actually registered at the runtime by the server, and it will be having a unique ID. So when you are actually authoring a relationship, you should be keeping it null. Talking about the evaluation query, so it is a Rego query. We have some of the Rego policy. We have a Rego policy engine which actually acts as a law enforcer or like a law house for the all the relationship, which actually enforces the rules or rule sets that we have defined in the Meshery logic to the relationships. So we'll be talking about them later because they are the high level concepts. Talking about the kind, as I said, so it is a core category of the relationships. It can be age, it can be hierarchical or like that. So it accepts those types of the relationships. So this is about the top level field that we have in Meshery relationships. Talking about the next field, it is a metadata. Metadata is for the user experience or is for actually identifying the relationships. So in metadata, there is a field called as a description. So it is human readable summary and it accepts the string. So you can give a long enough description for your relationship. For example, if you are creating relationship between a pod and deployment, you should be stating like what kind of relationship it is, what it will be doing, or how it can be useful. So this is for the description field. There is a is annotation field, which is actually decides if it is a non-semantic or it is a semantic. If it is a true, it is a non-semantic. That means it is just for the design purpose. And if it is false, it is semantic. That means it has something meaning. Talking about the styles are actually primary color, SVG color, and SVG white. So when you are actually looking at those kind of logos or like symbols, they are actually hard coded here. Like, I mean, they will be going here and it will be accepting the hex codes like this. So it will be having those things here. And that's how we can actually give them a logo or these things. Now, moving forward with the next field, it is a model field. For your visual map, let me show where it defines. So we defines ID field here. It is kept as null. It will be set as unique when a server will be registering it at runtime. Evaluation query is actually used to like explicitly set which evaluation engine or like which Rego policy will be evaluating this relationship. There is a kind age type of the relationship. This is a metadata block. As you can see here, the line color, line style, or all those things are defined here. So this is for the metadata. Talking about the models, so this is the field. This is the field which actually decides which component will be going in which directory. Now, this is for the Meshery shapes. So let me take another example. Okay. So here is the model field. Now see, there are two things. Here is a CSI node, which is from the Kubernetes model, right? And then here is a node which is also from the Kubernetes. But and that's why we have actually the model name as Kubernetes. Because what if we declare it as AWS? It won't work. Why? Because it won't be actually evaluating it because the model name is defined wrong here. All the models that we have are from the Kubernetes. So all the components that we have, that is CSI node are for Kubernetes, and this model should be matching it. And one more benefit of this model field is when you are actually querying the server, or like when you are actually trying to register or like to create a relationships using Meshery CTL, when you're trying to create a model or anything else, it used as a filter because in Meshery we have so many of the models. And when you are not defining a model field, it will be like a global field and it will be querying all the relationships, all the models, all the data it have, and it will be high complexity or like what we call as worst case time complexity will be there. And that's why we have model field defined here. So if you are taking the example, let me just twist your minds. For example, talking about the AWS, this is I think about Azure, Azure Network, Azure Key Vault, and this for the AWS one. Yeah, we have some of the AWS. This for okay, good. So see, here are two components: a broker from AWS MQ controller, and then a security group from AWS EC2 controller. Now, what if why we have created this relationship under AWS MQ controller model? I mean, we can definitely create it under AWS EC2 controller model too. Why we have created here? The reason we have chose a model here is AWS MQ controller, and that's why we have put it here. It's not like it won't work if I like register this, if I create this relationship under the AWS ECR mod EC2 model, but I need to define this model as EC2 also. So that's how it will be working. So talking more about this, so get back to slideshow. So this is how it works. So model, in terms of this model, so there is a version field too, and it is a version of the model. For example, in terms of Kubernetes, it was for RC.1. So this is the model of this is the version of the model in the top level. It is the name of the model that we use. It is a system name of the model. It actually accepts lowercase string only. Like you can't make this K capital or anything capital. So it actually accepts the lowercase string. If you are looking at the Meshery, you'll find most all the model name are in the lowercase. And the registrant. So registrant is a thing which actually defines the source of the model. For example, when I'm talking about AWS, models are derived from ACK controller. For Azure, models are derived from ASO controller, and those things are stored. ASO and ACK, which actually holds the CRDs, custom resource definitions, they are stored on the GitHub, and that's why we can call registrant as a GitHub for this model, and we can use artifact as a registrant. Let me show you the example of it. So here you can see registrant, you can see as a GitHub. Now, why registrant is a GitHub? If I'm going here in the MQ controller, this is the MQ controller component. Sorry, this is the broker component of MQ control. So if I'm going the components and the broker, you can find a link, a source URL here, and it actually points to a Git. That means GitHub, and that's why we called it as a uh, GitHub. So if there is any model or component or any relationship from the artifact hub, we can call that registrant as artifact hub. So yeah, let's move forward with the next. Now this is where actually the action happens. All the things were for the regulatory purposes. Now action begins here. Selectors block. Actually, in the selectors block, it is having two components like allow from and allow to. So let's talk about allow from, what it does. So let's say I'm talking about a pod and then a container, right? So for a container, or for a pod to consist a container, it requires the name of the container. It requires the image that you're using for the container, right? So for that, you need to put all those things like name of the container and the image of the container into the pods, into the pod spec section, and that's when you can run your pod. So this field actually does this ingestion task here. Now talking about the allow from field. Now let's go back to here. So this from array always contains the child, and the to array always contains the parents in context of hierarchical relationships. But since we are into this, so let's finish it first, and then we can move to the hierarchical relationships. So talking about the allow from field and allow to field, these two fields, can I know if you can see this, if I have slideshow turned off?
Yeah, we
Yes.
can see the Google
Like,
No, it's
Slides.
visible.
This.
okay, all right. So I can switch back to the ID also. So yeah, talking about this relationship here, you can find two fields in selector block here. This is selector block, and you can find two fields here. First is allow from, the second is allow to. So from and to are actually nested under the allow. And now what that does, what's the meaning of these fields? So from field and to field are actually shows the direction, and they dictates the structure for the whatever configuration will be happening. So talking about the from field, whatever component you have in the from field, for example, we have MQ controller here, and then in the to field we have the AWS MQ controllers broker. So when you are uh, dragging this adapted resource component on the canvas, you need to initiate the relationship arrow from the adapted resource only. You can't initiate the arrow from broker, because we have this in from field. From field says that, okay, this is the direction of the arrow and this is how the direction will be flowing. So this is the reason, this is the uh, usage of from and to field. Now moving forward, these are the same things like ID for the adapted resource. This is not for the model. This is for this component actually. If are even going for the component adapted resource, you can see it null. You can see it null. That's why it's set as null. So this is the ID for the adapted resource. Then this is a match block, and in the match strategy matrix, I'll be explaining this also, but let's see some of the familiar fields. So here is the model identifier for this component. That okay, this is the model identifier. We'll be using this model called as a MQ controller. This and the registrant is of the GitHub. So this is for the identification of the component, those fields, and then there are two fields called as mutator ref and then called as mutated ref. Now let's talk about them in the slides. So yeah, talking about the patch field, which actually contains mutated ref and mutated ref. So the mutator ref is the path to the data being extracted, the giver, the source of the data. For example, when I'm talking about a container and a container will be giving its data to pod. So we will be putting a container in the mutated ref and we'll be putting pod in the mutated ref because pod is receiving the data and mutated ref is providing the data. So the one thing I was confused about, I would like if you guys can take a note of this thing. Mutated refs or mutated refs are not bounded to the source, sorry, to the from or to fields. You can define mutated ref and mutated ref. Sorry, you can like you can define mutated ref into allow.from. No worries. You can define mutator refs in allow.from. No worries. And you can do same with true. So it's not like mutator ref should be only defined in allow.from field because you will be seeing mutator ref 99% present in allow.from field and mutated ref in literally in to field. But this is not like this. Mutator ref will be working when will be working with the source which will be giving the data, and mutated ref will be receiving the data. So this is the differentiable statement between them. And now talking about something called as a patch strategy. So it is a replace. So how the data is applied, it says how the data is applied. For example, here in this field, so data, how the data is gonna apply is, this is a replace field, right? So talking about this specific relationship, so it is a kind of age relationship. Then the subtype is reference and type is non-binding. So in terms of reference, it will be just referencing a value, maybe name, ID, or anything else. And same here. So now how you can read this relationship or how you can read this selector block, you can say that adapted resource block is actually giving this name or ID field to the broker component of AWS MQ controller, and in MQ controller, it will be replaced in the display name field of the, or as the display name field of the broker. And how it is gonna replace? Because we have set it as a replace in terms of the patch strategy. And remember, patch strategy is defined not just once, it defines once and twice. And both those strategies should match. You can't do that. Okay, here's a different one, here's a different one. There are some of the values, I'll be talking about them later. But this is the rule. And one more rule you should be taking a note of is the array size. You can see the mutator ref array size is of 1. We just have a one array, a single array. And then in terms of patch mutated ref, we are also having a single array. So you should be matching the size of the array here. It shouldn't be like in mutator ref, you have two arrays and here you just have one array. So this is the rule that you should be following while authoring the relationships. That's all. I know that it might be feel so confusing, and you know what? I'm still not sure about so many things in relationships because, as Lee always says, it's a juicy topic and it's just like a circular thing that one time you were feeling like okay, you are knowing everything, and at a time you just understand that you know shit about that. So that's how it works. And this is a two field. So as I said, it is a field which will be actually having the receiving, which will be on the receiving end, and this is the mutated ref, which will be data will be injected. So yeah, I think this it is clear about mutated ref from and to. Now there is remaining one more, deny. You won't see this field populated much in Meshery. That is deny from and to. It is same like selector from and to, but what it does is it actually is the explicit exclusion block. Like it defines that selectors that should never act as from or selectors that should never act as to. So you can populate this to make your relationships more stricter, and you can do that. So now let's move forward. So I have one topic left to explain, and it's about hierarchical relationship types. So talking about hierarchical relationship types, it is a really interested one. So let's talk about some of the subtypes of its of hierarchical relationships. First is hierarchical inventory relationship. Relationships between components where the configuration settings of one component, known as the parent, are combined or integrated with the configuration settings of another component. Then it is known as a child. So it is like inheritance type of thing. In object-oriented programming, we just inherit the things or characters of the parent, and just we inherit them for the child. So that's how it works. Now are some of the rules and regulation in terms of hierarchical inventory relationships. For example, the from array always contains the child, and then the to array always contains the parent. Now you might say, okay, if the from array always contains the child and the to array always contains the parent, now how data flow will be working? So let me explain it. Okay. So in terms of mesh relationship, let me just go parent inventory. This about MQ controller. Now it's here. So now this is a kind hierarchical, because this is a hierarchical type of relationship. Here is a description given that it is actually hierarchical inventory relationship in which the configuration of parent component is patched with the configuration of the child component. Now, if you are going here, then as per the rules that we have, for example, from is the child and the to array is the parent, right? So if you are looking here, you can see, okay, just this is not a relevant one, or maybe this is actually a wrong relationship. This is defined wrongly, and you'll find it so many times. So it's just confusing. Just give me time. Let me find a good one. Maybe. Yeah, it's good. Okay. So let's talk about this relationship between Azure. So it is about federated identity credentials, and then about Azure, between Azure managed identity, and the next one is here, user assigned identity. So these are two components, federated identity credential. You don't have to know about what those components are, what they use or what they do. They are just components. Just imagine they are the components, and user assigned identity. Now, as I said, allow.from field will be containing the child. So just assume this is a child, and then here in the to field, as we said, to field will be the of parents. So this Azure managed identity will be the parent. Now, as we said that in terms of hierarchical inventory relationship, actually the parent patch the childs. I mean, the parent will be giving its value or its characters to the child. Here we have defined it. Parent component is patched with the configuration of child component. So what will be happening here is, as I said, mutated ref and mutated ref defines who will be giving the data and who will be receiving the data. So two things to remember: from is always the child and to is always the parent. So what's happening here? If you're going here, you can see even after being in the to field, that means in the next end of the arrow in terms of Meshery canvas relationship, user assigned identity here will be acting as a parent and it will be giving its data. And that's why, since it's giving its data, it is called as the mutator ref, because mutator refs are those who gives the data. And then in the from field, this federated identity credential is receiving that data, and that's why it is called as the mutated ref. And the display name of that child, of that parent, will be patched here in the name, in the field name. So it is actually moving backward, not top down. It is actually bottom to top type of relationship, because the to field will be patching the from field. Now I know that it's might be so complicated, but once you have gone through docs, and then if you are watching this video, which will be available on YouTube later, you will be getting that. I'll be doing fast since we are we are running out of time. So talking about hierarchical relationship types, so it is of a hierarchical wallet type. So this is actually opposite of inventory relationship, where the child will be influencing the parent component. Now, what I mean by child will be influencing, let me show you. Let's take Kubernetes example, since Kubernetes can be put to use. Okay. So first thing you can notice here is, in last relationship, which we saw, it was hierarchical inventory. We had mutator ref in to, and then mutated ref in from. But here mutated ref is in from field. Sorry, mutated ref is in from field, and mutated ref is in to field, because it is top down relationship. That means this endpoint slice will be acting, as we said, it is acting as a child, and child will be patching the parent. So this child will be giving this value, that is kubernetes.io/service name, to service that is here inside the metadata, because mutated ref will be receiving the value. So that's how this relationship will be working. So this is about hierarchical relationship types, about wallet relationship. Now going forward with one more, it is hierarchical tag sets, that is match labels. So this represent relationship between components of same labels or annotations, key value pairs. So it is just something for the design purpose, like you can show the relationship between a node port or a sample app. Since a node port will only work if it is having a good, if it is having a label which is also in the my sample app. So that's why we are given it as a hierarchical relationship type. So let's go here and check one if I have one. Right, tag set. Pretty sure we'll be having one. So yeah, this is for all the kinds. You can see no any component is mentioned here. And since here is also no any component is mentioned here. And what does it mean is, as you can see here, it is just to match the labels in Kubernetes for all the kinds or components that we have. Star means all. This asterisk means all. So as you can see here, you can't see anything like mutator ref or mutator ref here. You can just see the refs. Just see the ref, because no any patching is happening here, and that's why no any mutated ref or no any mutated ref is here. So it will just be checking if configurations metadata, and inside the configurations metadata labels, the labels field are equivalent or same or similar or not. So this is what it will be doing. And in terms of patch, as I said earlier, if it I have set it as a replace one, it would have the patch the value. But since it is giving red, because it shouldn't be replaced. Why it shouldn't be replaced? Because it is not actually the relationship which will be actually patching the things. It will be null only, because we are not making any action here. It is just for the visual purpose. So that's how mesh relationship is working. So it's all about the types or all things about mesh relationships that we have, about types and all those things. And I'm hopeful that you are actually aware of the schema. I would like to round up like it says 6 minutes. So can we continue or not? I just have some topics left, so maybe if you can.
Um, would you like to continue this as another session for this if the topics are a bit
Yeah,
time
no
taking?
worries. It will be really nice because it's a vast topic and it needs to be understand really well. So I can do that
Yeah.
later. No worries. But for now, stage is open for any question if you have.
Yeah, I can I ask a question?
Yeah, you can.
Yeah, that's some interesting information. And I just had a question about like these declarative YAML relationships that are defined in these models. So how are actually they working under the hood? Like, for example, we have allow.from and to. So is OPA, is that driven by OPA policies to something like pass this YAML and then implementing and using OPA under
If
the
you are
hood?
going,
Or
yes, if you're going into the server fields, for example, we have those type of rule sets defined. As you know that in terms of like uh, to govern the relationships, we have OPA policies, Rego policy engine. So there is the rules are actually set. For example, a simple rule called as the mutated ref and mutated ref, like here,
Mhm.
they should be having a same number of arrays. As you can see, you can actually see two arrays here, right?
Yeah.
Same happening here. We have the two arrays. So it is same of that. Let me switch to slides. So it is actually same of that whenever you are actually uh, working with relationships or that, and whenever actually server is importing them, server is actually trying to run them. It is doing the same thing. Like what it will be doing is uh, parsing those relationships or those things against the relationship or against the relationships that you have. For example, let me just move to slides. Can you see the slides?
Yeah.
Yeah. Okay. Let me see. Okay. I'm just trying to find those rules specifically because I don't remember where I can find those files.
Mhm.
Yeah, there's these files are actually under servers, maybe mesh model, mesh model. Yeah, you can find some of the Rego policies inside mesh model.
I think some of them are in Meshery
Yeah,
core, mesh models, and then
yeah, you are
version
right.
policy.
You are right. Just a minute. Just quickly find them. Okay, got one. Yeah, found one. Nice. Can you see my ID?
Yeah.
Yeah. So here is one of the Rego policy that we have. For example, if you are going and see here, this is the evaluation rule here. For example, if you are taking a look, we have some of the policies defined here. For example, to ensure for just for specifically for the age and non-binding types. So this is how they are actually defined here in terms in I think server mesh model and then inside Meshery code. You can see all the operations like all the actions like talking about this relationship. You can see those things here like all the things like actions to be taken on relationships like to update or the path or value or those things. It is just a high level thing to actually explain this because it works under the hood of the relationship. When you are doing those things, you can't see those things happening, but as you know on the canvas, when you are on the canvas, there is a if you remember that thing, there is a wheel that spins. So when that spins, actually
Mhm.
it summons those rules, and according to those rules it works. For example, if you are talking about this block, for example, patch mutators actions. So it defines like how mutators will be taking the actions on. For example, in from selector allow from to selector allow dot, and this is the index that we have actually defined. So it is a logic that actually works to evaluate or govern those relationships. It's not like we have defined something or like we have hard coded the things like okay, mutator ref is this or mutator ref is that. We are actually having the ref. We are actually having the rule sets of in the Rego that will be helping to actually evaluate or work on them. You can find so many of them. For example, for hierarchical parent, You can find those rule set here. You can find for binding policies. You can find for helper rules or so many things here. So this is just bit of out of scope currently because since we audience is not aware of those things, but this is interesting part you can work on. So this is how it helps. Rego engine will be governing all those relationships and will be evaluating the policies. And there is OPA policies defined that actually holds a rule set that okay, we have those policies defined and this is how it should be, this is how it shouldn't be, and that's how it works under the hood. I hope I satisfy your query, Ronak.
Yeah, in a great way. And I just had another question, like how if one can want to contribute to mesh relationships, so how they can
Yeah,
find specific issues on what relationships we have to define and to
that's
get
actually
started with
the
the pattern.
yeah most perfect thing to start with Meshery for the newcomers is the relationship, because you know what, there are thousands of relationship needers, there are thousands of relationship needers. If you're going on this particular model, there is no any relationship defined yet. So
Mhm.
you can just define as many as you can. So if one want to define the relationships, I will say just go here and start contributing the relationships. It's the best way to start with the relationships and in the Meshery. If you are learning about the Meshery, it's a really nice thing. If you are going even for the Azure, Azure is one of the high demand thing, but we have just like one, two, three, four, five relationship for it, and there are needs of many more of them. So you can just go search which relationship is needed, and you can just learn about the relationship and start actually working on it. And yeah, one more thing I will be demonstrating quickly, if you don't mind, Ronald.
Yeah.
Just a quick
Mm.
demonstration it will be. Okay, so I just integration spreadsheet, Meshery. So we have integration spreadsheet or as a Meshery. Integration spreadsheet. Yeah. Meshery integration spreadsheet. Oh, sorry, I just here it is. So Meshery integration spreadsheet is a single source of truth for all of the integrations that we have. You can see some other tabs like models, components, relationships, and all others. Let's just focus on these three. So these are the models that are being defined here. These are the registrants, a GitHub artifact hub where they are sourced from. These are the source URLs. These are actually the CRD URLs of those. You can see those for the Azure service custom resource definition that got just downloaded. So these are the CRDs, and these are all the things that have been defined here. If you are going here, you can find all the models. Then it is a component tab. You can find all the components here. And then in terms of relationship, since we are focused on relationship, so now just notice on some of the things. If you can look at the here, selectors dot allow from allow to. So these are the fields that we actually saw or the selector in this relationship files, right? So actually this spreadsheet is a good way to create relationships. Now how I will be showing. So what you have to do is I have some of the, you just have to write your relationship file here in the blocks. For example, give you a model name, then just select your type of the relationship that you want here. Then you can do that same with like injecting the structure here. For example, selectors allow from fields, then selectors allow two fields. Then this is the selector field as a whole. You just don't have to input this here. It is just auto generated by the formula. It will be generating a name, and then this is how it will be working here. And if you go here in this topic, you can find the whole JSON schema that we use for the relationships. It is just bounded with a formula. For example, in terms of kind, it is, if you're seeing here, can you see this, which I'm highlighting?
Mm. Mm.
Yeah, it is referring to the field C558. That means the C558 is C558 is this. So it will be injecting this hierarchical column here in this C558 because the kind is hierarchical. So you just have to, what you have to put here is put a name, for example, AWS, then put let's say Kubernetes, put a name, then a type, age, non-binding network, then give a description, then allow from kind and allow to kind the components that you will be using. Then just write a relationship here, and after that what you have to do is just go here. Since this is just for the maintainers, no one can have access to this. Just go here and download as a CSV. This is the latest enhancement by Lee, which will be letting you create any relationships. For example, I have some of the relationships actually downloaded, or like downloaded those CSVs. So this is the command Meshery CTL registry generate. It will be taking model CSV, component CSV and relationships CSV as a input, and it will be creating the models. For example, let me create models for AWS ECR controller. Now, why ECR controller? Because I have ECR controller repository. Let me just switch to server directory. Remember to run this command from the server directory. So if I'm going here and just again copy pasting this command, so it will be actually generating the relationships from that spreadsheet. I have downloaded that spreadsheet as a CSV actually. So let's see. Okay, see, and it has actually generated the relationships. My server is broken, that's why it is showing the error, but it has created the relationships. Now let me show you where I have created the relationships. If I'm going here, see the mesh model is green, and if you are known about why this is green, because this file has been modified. And as you can see, the versions are in green because they have been modified. Go here, but just notice that only relationships have been modified, and here are the relationships that are got defined. Now you will be saying like how this relationship came from, where this relationship came from. This relationship actually came from my CSVs, which I have generated. Let's see, let me show you guys that that one. AWS ECR, yeah, here. Okay, so here are the relationships that actually I had defined. Okay, so these are the relationships that I had defined, AWS ECR or all those relationships. I defined it on my own. It was not like auto-generated or anything else. I have to define them. And after that, if you might see, okay, there is AWS ECR, there is AWS Kinesis controller, S3 controller. There are so many relationships. Then why it just generated the relationships for AWS ECR and not for AWS S3? Or one more thing, it just created the relationships, not components or models. Why? I mean, it could have created a AWS ECR controller model. The reason is, just look at this command. I have specifically set a model AWS ECR, so it will be only passing the AWS ECR controller model. And the reason why we have this top model field here satisfied here. So that's the reason why it's beneficial here. So this is the reason why we need to define this model things, or like, okay, this is the model. And this component and component.csv model or csv relationship.csv are actually this CSV files that actually made copy because no one should be editing that original sheet. So this is how it works, and you can define the relationships manually also. But remembering the time we have, let me stop here. You can ask any question. Oof.
I have a question. So,
Yeah.
while you were explaining the relationship part, there was one file called just it was one of the components, and it was in AWS MQ controller, and it's the file name is broker.json. So I saw that there was a in place of source URL, uh, in the metadata, in place of source URL, it was not URL, it was URI. But doesn't that affect the relationship by any sense?
Can you just tell me the name of the file?
Yeah, it was broker.json, and it was in the components folder of
Yeah, I found it.
version. Yeah, yeah, yeah.
Yeah, I found it. No, it won't be making any issues. Source URI is actually a thing which we use everywhere. For example, if you are even going to any other you can find this field, for example, just yeah, in even the field export.json, you can see it is same. So it's not like you should be using the URI. If you are taking a look carefully, then it is actually a source URI everywhere. So yeah, there won't be any problem with that. It will be just going and parsing those relationships.
But like, what does URI mean here? Like, was it supposed to be URL, or like, is it supposed to be URI?
It is supposed to be URI. I can deep dive into schemas actually about that, because there is a schemas defined for it. And let me just find that file so I can give you definite answer. Just a minute, let me find that file. I'm just getting some calls. Okay, this file. Yes, so the answer, where the JSON files, JSON files, JSON files. Okay, so the reason is like when you are finding the schemas like inside
You are
the
not sharing it.
oh no, I'm not sharing the file actually. I'm just going on GitHub and seeing the schemas file in the schemas folder. So in the schemas folder, schemas is actually a place where we have stored the schemas for the Meshery. It is a repository. So it is having all the schemas defined, and there you can find that the reason why it is source URI and not source URL. So the reason why it is URI not URL is URL is a locator. We call it as a uniform resource locator, and it strictly like implies what we can say as for example a web address that you can fetch using a standard web protocol like HTTP or HTTPS. But when it's about URI, it is an identifier. It is uniform resource identifier, and it is a broader superset. So it can be a web address, but it can also be a name, what you can say, name of a specific specialized protocol scheme, right? So why Git is using, we are using those URI is because the generator needs to support pulling models from sometimes Docker or OCI registries or Git repositories, or maybe some of the local file paths. And source URIs, that's why is a technically correct term to encompasses all these different schemes. And that's why we are not using locator, but we are using identifier to identify those sources.
Okay, thank you. I got the answer. Thank you very much.
Yeah, thanks. All right, so I think we can leave. Right?
Yeah, I think we don't have any questions. So we are also 24 minutes up time, but that
Yeah.
was a really insightful
Maybe we
session,
need one
Yash.
more session. Yeah, maybe we need one more
Yeah,
session.
yeah.
Yeah,
So we'll be seeing you on the next session for the next Friday, same time. And you can find the recording of this video on the Meshery.io YouTube channel in the live section. And feel free to reach out to Yash on Slack
yeah, definitely.
to have any more queries and interactions on this topic. So yeah, yeah. Till then, have a great day and bye everyone.
Yeah,
Yeah.